welcome back to DTS Programming. Today I'll be presenting my project sorting for my CSC382 course, Data Structures and Algorithms at the University of Advancing Technology. So for this project, our overview is to code or implement a sorting algorithm of our choosing, i.e. an insertion, merge, sort, or quick sort that operates on a linked list data structure. And there's an expectation to test the program accepting an array with a minimum of 20 integers. So for my project, I decided to go with an insertion array. The primary point of this project, aside from creating a proper insertion sort method, was to evaluate how long it took the program to sort the nodes in the program with a minimum requirement of 20 nodes, and then we were to evaluate 100, 1,000, and 10,000 nodes. You can see here in the expectations. And for anything less than 100, the program should print the sorted list. So I'm going to demonstrate quickly what I have. Here you see my main menu, just a few options to define the number of nodes you want to evaluate. We'll start with 20. So here you can see that I have an unsorted list that is created and randomized. Um, the head value and tail value are defined, 47 and 14, and the size 20. Um, Next, I have the actual evaluation. Program sorted 20 nodes. It did so in this amount of time, 0.0004001. And here you can see the sorted list and the new head and tail values 2 and 66. And that is correctly sorted. For 100 nodes, same thing. An unsorted list is created. Head and tail are defined, 117, 122. 100 nodes, sorted in 0.0001974. And here you can see the sorted list and the new head and tail 1 and 149. For 1,000 nodes, you see I just went ahead and defined the head and tail values and the list size, the sorted time 0.0380, and of course I didn't display them on the screen because it's 1,000 nodes, but you can see the head 311 and tail 112, and here 1 and 1049. And for 10,000 nodes, takes a little bit longer, but there you have it, 1.979. Head 1262, tail 6778, head 1, tail 10,049. So moving into my code, you can see here in my main function, all I do is call the main menu. In my main menu, of course, I'm only displaying the options menu, and from there I'm taking in the option from the user and verifying. So this function is called to verify that the option chosen is valid. Just a little bit of error checking. For my verify, I check if the option chosen was a number. If the option was not a number, it's going to loop this while loop until a numeric value is entered. So if the option passed in is a number, we don't go into this while loop. We'll hit this if statement. We'll check if the option is between 1 and 5. If it is not between 1 and 5, then we'll recursively call this verify function and check the new value passed in. And that will loop until the proper value is selected by the user. And then we'll drop to this call option method. The call option method is basically going to take in the number, the option selected by the user, and then it's going to make sure that the next function is called with the proper value selected from the menu. So as you can see very clearly, case 1, I call my sort analysis with 20 passed in, then 100, 1,000, or 10,000. In my sort analysis with the passed in number of nodes, I create a new doubly linked list called list to sort. I clear the console, I create a stopwatch object, I initialize some variables with some default values, a head value, tail value, and my list size. Here I generate a random non-repeating list. So let's drop to that function real quick. Generate random non-repeating list takes in the size of the list and the list itself. Starting off, I create a hash set called node values with the size passed in. I have a random object called rand here. Then we'll go into this while loop. We'll check if the count of the hash set is less than the size passed in. Then we'll continue to add random values to that hash set until we reach the size of the list. And here you see that I'm choosing a random number between 1 and the list size plus 50. Then we'll go into this for each loop, and it'll check for each node in my hash set, for each value in the hash set. We will call our list object and the method insert node at tail. So for each loop, a node will be inserted at the tail of the list. And then we'll return that unsorted list here. So now that we have an unsorted list set here, we set our head, tail, and list size by calling our methods from our doubly linked list object, our list sort object. Get head value, get tail value, get list size. Here we're just displaying a header. We're checking if the number of nodes is less than or equal to 100. Then we're going to print the list. Otherwise, we're just going to display the head, tail, and list size values. Start the stopwatch. Call our insertion sort method from our doubly linked list object. Stop the stopwatch. I'm going to display how many nodes were sorted and the time that elapsed. I'm going to show that this is the sorted linked list. Again, if the number of nodes is less than or equal to 100, we'll print the sorted list. Again, showing the head, tail, and list size. And then pausing the program so that everything can be viewed properly. Once this is done, it will return to the main menu. So I have a node class defined here. In my program, I am using a sorting library. In my node class, I've defined some member variables called data, previous, and next. Then I have my constructor, which takes in the data value for the node created. Here we set this data equal to the passed in data, and we set our previous and next values to null. For my doubly linked list class, again, member variables called list size, head, and tail. My constructor, which initializes my head and tail to null. I have an insert node at head method. Insert node at head takes in the node data. It creates a new node object called new head node and passes in the data for that node. Checks if the head does not equal null. Sets the previous head.previous to the new head node. Then it sets the new head node next to the current head, and then it assigns the new head node as the head. Otherwise, if the head is null, then the head equals new head node and will be the only node at this point. Then we set a temp node equal to the head value, and while that temp node dot next does not equal null, we're going to increment through the list until we get to a null value, which is the end of the list, and then we will define the tail when we get to that last node and increment the list size because a new node has just been created. Very similar, insert node at tail, passing in the data for that node, creating a new tail node object with the passed in data, checking if the head equals null. The head equals null, then we're going to call the insert node at head and pass in that data. So we're just sending it here to create the first node. Otherwise, if the head is not equal to null, then we will set the tail.next equal to the new tail node. So the current tail's next value will be this new node coming in. The new tail node's previous value will be the current tail. and then this new tell node will become the new tell, and then we'll increment the list size. And of course this works because the tell value is set in the insert node at head, which is why I've defined it up here. So when it drops into this else statement, the tell node is already defined. Here we have my print linked list method. This is just going to go through the list. So we create a temp object and set it to the head value. While temp does not equal null, we're going to write the data for that node and then increment to the next node. And this will continue to loop until it's gone through the whole list. We're going to skip past this for just a second now and just take a look at our getters. Get head value, get tail value, get list size. Just basically returns this head data, this tail data, or this list size. Whatever its value is at this point, at the point in the program where it's called. Going back into my insertion sort method. So starting off, I've created a node object called current and a node object called scan node and an integer temp, which is going to hold our data value, a temporary data value. And I have a diagram as we go through this insertion sort. So here at the beginning, we have a node called current. I've got current defined here as green. Current gets set to head. And then scan node, scan is blue, scan gets set to head. So the head value is set to current and scan node once we drop into this method, and temp is equal to 0. The first thing we do is we increment current to current.next, so this becomes current. We check while the current does not equal null. Scan node equals the head. Scan node is already the head, so on the first run there's nothing to be done here. And for each loop in this while loop, we're checking if our current value does not equal null. So the current value does not equal null. The scan node is set to the head. We'll go into this inner while loop. And while the scan node does not equal the current, so while this is not this, then we're going to set our temp value to equal the current data. So our current data here at this point is 2. So we'll set our temp to equal 2. So our current data will be equal to our scan data. And our scan data will be set equal to our temp data. So you can see that first swap has been made. Then it's going to go to the while loop again. It's going to check scan node does not equal current. It does not. So it'll drop down to this else statement, and it will increment the scan node to the scan node.next. Then the while loop will check again if scan node does not equal current. The scan node does equal current, so it's going to drop out of this inner while loop, and it's going to increment current to current.next. Then this while loop is going to run again. I'm going to check is current equal null. Current does not equal null, so scan node gets set to head. And then we'll drop into the inner while loop again and do the same thing. While scan node does not equal current, it does not. If the scan node data is greater than the current data, which it is not, then it is going to increment the scan node. So we'll go here, we'll check again. Is it greater than the current? No, it's not. Increment. And now they are the same. So it'll check scan node equal current. Yes, it does. Current equals current.next. Again, is current equal to null? No, it isn't. Scan node is going to be equal to head. And then it's going to evaluate, is scan node greater than current? No. No, it is not. Yes, it is. So we'll set our temp value equal to our current data, which is 7. We'll set our current data to equal to our scan node data. So we'll put, this will become 14. And then our scan node data will equal our temp data. So that will now become 7. Then we'll check while the scan node does not equal current. Scan node does not equal current, and we'll check if the scan node data is greater than the current. It is not anymore. So we'll drop down to this else statement, scan node equals scan node.next. Now scan node and current are the same, so we'll drop out of this inner while loop and increment our current value. We'll check if current is equal to null. It is not, so we'll set our scan node equal to the head, and then go through the process again. Is 2 greater than 22? No, it isn't. Is 5 greater than 22? No, it isn't. Is 7 greater? No, it isn't. Is 14 greater? No, it is not. And so our current will equal our scan node, or scan node will equal our current. We'll increment our current, and there are no more nodes, so we're at our tail. So this will now evaluate to null. So we've went through our entire inner while loop, incremented our current, it now equals null. So we evaluate while current does not equal null. We'll drop out of this while loop, and we will return the sorted list. So that's simply how the insertion sort method works. It's just going to go through and check each value and then compare it to all previous values in the list until the largest values are in the back and the smallest values are in the front. So just to show it one more time, we have our unsorted list, head 41 tail 59. Time analysis to sort the list is shown here, and then we have our displayed sorted linked list. So as this runs through, as the program evaluates this list, it's going to first set this value as a scan node in the current node. It's then going to increment the current node. It's going to compare the two values. Is this greater than this? No, it's not. This scan node is going to increment, and the loop is going to, then the current will increment on the outer while loop. Then it will check again, setting the scan node back to the head. Is 41 greater than 9? Yes, it is. So 9 will be set to temp. The current node will be set to this node's value, 41. 41 will then be set to the temp value 9. So now it will be 9, 52, 41. Then the scan node is going to increment ahead, and it's going to check is the scan node value greater than the current. At this point, it still will be. 52 is greater than 41, and so 41 will get stored in temp, and 52 will be set to the current value, and the current value will be set to the temp value, which would be 41 at that point, and so you'll have 9, 41, 52, and it will continue that process until all the nodes get sorted out properly. So pretty straightforward this week. That was my sorting project for my CSC382 Data Structures and Algorithms course at the University of Advancing Technology. Today I was able to show how to implement a insertion sort method that works on a linked list that takes in a minimum of 20 integers and that evaluates 20, 100, and 1,000, and I added 10,000 numbers for our analysis. So that is my project sorting. Thank you.